This is the brief on concentrated source modeling and transport phenomena. So, what's this all about? We're looking at how to model something incredibly concentrated, like a tiny burst of energy, often using what's called the Dirac delta function. And from there, we see how physical boundaries and forces take over and control how everything spreads out. First, how you model that source completely changes the outcome. You see, if you model it as a single perfect point, you get a mathematical oddity called a singularity, an infinite spike. But, and this is the really cool part, if you just spread that same energy out over, say, a line or a sphere, poof, that singularity completely vanishes. You're left with a totally smooth, realistic field right at the center. Second, once that source is out there, its fate is governed by a constant competition. On one hand, you have physical forces. Convection acts like a wind, carrying the pulse, while diffusion spreads it out and weakens its peak. On the other hand, you have the boundaries of the space itself. An infinite space means endless spreading, but finite walls, they force a final outcome, either by absorbing everything or by trapping it and forcing it to an average uniform state. So it really boils down to this. How you define that initial concentration and the boundaries of the system are what determine the fundamental outcome.